We now discuss the solution of a problem from the integral calculus, and the problem is to evaluate a given definite integral. This question has appeared in joint entrance examination main held on 27th July 2021 in the shift S1. The problem is the value of the definite integral from the limits minus pi by 4 to pi by 4 dx by the product in the denominator, the product, the first factor 1 plus e power x cos x multiplied by the second factor sin power 4x plus cos power 4x is equal to. We are given four options. Option 1 pi by root 2. Option 2 minus pi by 2. Option 3 minus pi by 4. Option 4 pi by 2 root 2. We now discuss the solution of the problem in detail. We want to compute the value of this given definite integral. Let I is equal to the integral minus pi by 4 to pi by 4 fx dx, where fx is this function 1 by, in the denominator, the product 1 plus e power x cos x multiplied by the second factor sin power 4x plus cos power 4x. Now, I is equal to the integral minus pi by 4 to pi by 4 fx dx, this one. Call it as the equation 1. We recall this result. The integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. Now, I is equal to the given integral minus pi by 4 to pi by 4 fx dx. Now, apply the above result. Then, integral minus pi by 4 to pi by 4 f of a plus b minus x, the lower limit pi by 4 plus the upper limit minus pi by 4 minus x, and pi by 4 minus pi by 4 cancels, and you will get integral f of minus x dx from minus pi by 4 to plus pi by 4. That means this now replace x by minus x in the integrand. That will be equal to integral minus pi by 4 to pi by 4 dx by, wherever there is x, you simply write minus x cos of minus x sin of minus x whole power 4 cos of minus x whole power 4. In this, cos of minus x is cos x. So, in the first factor it will be 1 plus e power minus x cos x only. So, the first factor. And the sin of minus x is minus sin x, and to the power of 4 will be sin x to the power of 4 and cos to the power of 4x. So, we got this one. For this e to the power of minus x cos x, we will write 1 by e power x cos x and take the LCM and send this factor to the numerator. Then we will get that as integral minus pi by 4 to pi by 4 dx 1 plus 1 by e power x cos x. So, for e power minus x cos x, we have written this one, and take the LCM, then you will get e to the power of x cos x plus 1. Send this e power x cos x to the numerator. So, that we normally do it. And that will be integral minus pi by 4 to pi by 4 e to the power of x cos x by 1 plus e power x cos x into sin power 4x plus cos power 4x with respect to x. Call this as the equation 2. Now, we go to the next slide, and we have that those two equations, equation 1 and equation 2. And notice that the denominator in the integrand is the same. Now adding these two, you will get 2i this side, and the denominator will be the same, and the numerators are to be added. And that will be 2i is equal to integral minus pi by 4 to plus pi by 4, 1 plus e power x cos x, the numerators, by 1 plus e power x cos x first factor multiplied by sin power 4x plus cos power 4x with respect to x, and the common factor is there. Cancel off those, cancel that you will get minus pi by 4 to pi by 4 dx by sin power 4x plus cos power 4x. Now what we observe is the integrand here, 1 by sin power 4x plus cos power 4x, is an even function. Therefore, this I will write it as 2 times integral 0 to pi by 4 dx by sin power 4x plus cos power 4x. Now 2i is equal to 2 times of this integral, so 2 cancels. Thus we get I is equal to integral 0 to pi by 4 1 by sin power 4x plus cos power 4x with respect to x. So practically this is the integral what we have to evaluate. We do it in the next slide. We have this integral, yes. To evaluate this integral, the present integral, in the denominator we take a cos power 4x common. So we'll get integral 0 to pi by 4 dx by cos power 4x. If I take it, this will be sin power 4x by cos power 4x, that is tan power 4x plus 1. Yes, we send this 1 by cos to the power of 4x is secant to the power of 4x. That we write it as secant square x multiplied by secant square x. For the first secant square x, we write 1 plus tan square x. Thus we get 1 plus tan square x multiplied by secant square x dx by tan to the power of 4x plus 1. Now put tan x is equal to u, right? Differentiate. Secant square x dx is equal to du. What happens to the limits? When x is equal to 0, it will be u is equal to tan x, that is tan 0 is 0. When x is pi by 4, u is equal to tan pi by 4, that is equal to 1. So the integrals now become I is equal to the integral 0 to 1, and for this 1 plus u square, and secant square x dx is du by u power 4 plus 1. Agreed. And now we take a u square common in the denominator. Then you will get u square multiplied by u square plus 1 by u square in the denominator, and the remaining integral is the same. We continue here. So now that 1 by u square, send it to the numerator. Then it will be 1 by u square times 1 plus u square. So 1 by u square multiplied by 1 by u square. 1 by u square multiplied by u square is 1. So 1 by u square plus 1 by this. Now make some adjustments, and that is equal to integral 0 to 1. The numerator is same. The denominator is written as u minus 1 by u whole square. Then we will get u square plus 1 by u square minus 2 times u into 1 by u cancels, minus 2. But we have only u square plus 1 by u square. To balance that, plus 2. We have added. Agreed. So the integral remains the same. Now substitute u minus 1 by u is equal to v. Differentiate. The derivative of u is 1. The derivative of minus 1 by u is 1 by u square with respect to u is equal to dv. And that is precisely the numerator there. 1 by u square plus 1 du. So what happens to the limits? When u is equal to 0, it will be 0 minus 1 by 0. That is 0 minus 1 by infinity. That means v tends to minus infinity. When u is equal to 1, it is 1 minus 1 by 1, that is v is 0. So the limits now become minus infinity to 0. So the above integral I is minus infinity to 0, and 1 by u square plus 1 du is dv by v square plus 2. Now that I have written as v square plus root 2 whole square. Now I recall integral dx by x square plus a square is equal to 1 by a times tan inverse x by a. The same thing I will do here. That will be equal to 1 by root 2 tan inverse v by root 2 to be evaluated from minus infinity to 0. That is 1 by root 2 tan inverse for the upper limit 0 minus tan inverse for the lower limit, it is for v minus infinity. And tan inverse 0 is 0 minus tan inverse minus infinity is minus pi by 2. So that will be 1 by root 2 into 0 minus, and tan inverse of minus infinity is minus pi by 2. And minus into minus plus pi by 2 root 2 is our answer. And let's look at the options. Our answer pi by 2 root 2 appears against option 4. Therefore, our answer is option 4. So that is the discussion of the solution of the problem from integral calculus based on the concepts of definite integral. It is certainly little, it takes little longer time, I'm sure. But however, some questions will be there in the examinations. Some of them will be like this. And I hope that you have understood the solution of this problem. Go on working out some more problems on these lines. I wish you all the best. Thank you.